Hello everyone, this is Lakshmi. Welcome to my channel Lakshmi Lucky. Yeah. Now we'll discuss my fourth theorem, the functions. The statement has given here f is a mapping from A tends to B, be a bijection. Then show that f composite f inverse is equal to IB and f inverse composite f is equal to IA. Okay. So here f is a mapping from A tends to B is there. This function is nothing but bijection function. F is a bijective function. Bijective means what we are saying should be satisfies one to one and onto function. Right now, so by using that one, we'll prove these two cases. F composite F inverse equal to IB as well as F inverse composite F is equal to IA. Okay. Now here given f is a mapping from A tends to B is a bijective function is there, no, and its inverse function is nothing but should become f inverse is a mapping from B tends to A. It is also bijective function only. So here to prove first case f composite f inverse is equal to IA or it should be is equal to IB or f inverse composite f is equal to IA, whatever. And the first I am proving this condition now. Okay. Yeah. Now f is a mapping from A tends to B is a bijective function already given in the statement right now, and its inverse function is nothing but what is there f inverse mapping from B tends to A should becomes inverse case. Okay, and composition of these two functions f inverse composite f is a mapping from A tends to A itself. A tends to A. Okay. And clearly we know that identity function is nothing but what how can we define identity is nothing but also mapping itself should be exist right now. So IA is a mapping from also A tends to itself only. So here F inverse composite F and IA in this have the same domain common right now. So here A is nothing but any one of the element in capital A you should take. And inverse of this function is a mapping from B tends to A is there, no, satisfies, it is bijective means it should be satisfies onto condition right now. So by the definition of onto, what is there? Every element in codomain have the pre-image right now. So here it should be exist. B is nothing but element in B you should take such that f inverse of B is equal to A, because here function is f inverse. F inverse undi kabatti f inverse of B we are taking, it should be is equal to A. Okay. So here f inverse of B equal to A. This f inverse you should take on the right hand side or you should apply taking on both sides f because here f inverse of B is equal to A is there, no. I am taking on both sides f f inverse of B is equal to f of A. This f I am taking on both sides. But here f inverse of B is equal to f of A we can write. F inverse is nothing but identity. Okay. Is equal to f of A. Identity is nothing but you should multiply whatever it may be. Identity function of B is nothing but equal to B only. It should be is equal to f of A. Okay, so that's what we are getting here. F of A is equal to B. So therefore here F inverse composite F of A should consider F inverse composite F of A is equal to, we can write this composition function F inverse of F of A. But here F of A is nothing but what is there from this condition B. Is it right So write here instead of F of A this B. Okay, and f inverse of B also what is there here? F inverse of B is nothing but A is there, right? Instead of f inverse of B, A. Okay, that means f inverse composite f of A is equal to A. A is nothing but identity function we can take. IA of A we can write. So therefore on both sides A is common element. So therefore what we can take f inverse composite f is equal to IA. That only we are taking. This is the required condition, no? We are proving we need to prove this condition only, na? So we got that condition F inverse composite F is equal to IA. Okay, and now we need to prove one more condition is there, that is F composite F inverse is equal to IB. Okay, now in the same way, F inverse is a mapping from B tends to A, because F is a mapping from A tends to B is there. Its inverse function is nothing but should become B tends to A, and F is a mapping from A tends to B is there. These two are nothing but functions as well as bijective functions, and its composition functions. Its composite functions F composite F inverse are nothing but B tends to B. Okay. F composite F inverse is a mapping from B tends to itself. So clearly we know that identity function with where B is nothing but also nothing but mapping from B tends to itself only. Okay. So here identity function IB and F composite F inverse have the same domain in both the cases. In this case also, right now. So that's what you should take any one of the element in B. So I'm taking B as an element in capital B. And since we know that F is mapping from A tends to B, means this function is nothing but satisfies the onto condition. Is it right, ma'am? So onto means by the definition of onto, it should be exist any one of the element in domain you should take, and such that its image is nothing but equal to B. F of A equal to B. Okay, and F of A equal to B means and again this function you should take right side, it should become F inverse of B is equal to A, or you should take on both sides in inverse function. Okay, F inverse toti multiply cheyandi, F inverse taking on both sides, F inverse F is nothing but identity, we should get A, and F inverse of B we should get. Okay, anyway make this equation 2, and here the left hand, now you should consider F composite F inverse of B. Okay, we are considered this one. F composite F inverse of B is equal to, again we can express like this F of F inverse of B. Is it right? So F of F inverse of B means F of F inverse of B, what is there from equation 2? F inverse of B is nothing but A is there. So F of A. Yes, no? And F of A is also from equation 1. F of A equal to what is there? B. So instead of F of A, you should take B. So therefore, left side what is there? F composite F inverse of B is nothing but equal to this B. We can write identity function IB of B. Nothing will happen, no? Value will be changed. So we can write instead of B, IB of B also. So therefore here common element B is there. So therefore we should get F composite F inverse is nothing but equal to IB. Okay, these are the required conditions now. This theorem also very important theorem for 7 marks. Okay, in these theorems any one of the theorem will come definitely. So perfect ga practice cheskoni exam ki velte definitely one theorem you can attempt. All the best. Yes. Now we'll discuss one problem. This is also important. This type of problems will come. Okay. Yeah. Show that what has given here. The function is nothing but mapping from Q tends to Q. That means F is a mapping from Q tends to itself. Identity function existed, and it is defined by the function is nothing but has given here f of x is equal to 5x plus 4 as a bijection, and find f inverse. So in this we need to find two conditions. In the first, by using this function we need to show given function is bijective function as well as inverse function. Okay, now one by one we'll prove my here. And given function is nothing but what is there here, f of x is nothing but equal to 5x plus 4. Yes, no? Make it equation 1. And bijection means what satisfies 1-to-1 and onto conditions, right? No? First we'll show 1-to-1 condition and onto. Okay, now for 1-to-1 you should take any two elements in Q. Okay, so here I am taking x1 x2, the two elements in Q I am taking, and by the definition of 1-to-1 condition, if A1 is equal to A2, then f of A1 is equal to f of A2, right? No, in the same way here x1 x2 belongs to Q I am taking, so that means by according to the definition of 1 to 1, f of x1 is equal to f of x2, right now? So here f of x1 is equal to f of x2 means here f of x is nothing but what is there, 5x plus 4. Okay, so instead of x you should take f of x equal to this one means 5x1 plus 4 we can write. Instead of this, it should be is equal to on the right hand side f of x2 means 5x2 plus 4 we can write. Okay, by using this, and on both sides plus 4 is there, positives, so 4 gets cancelled. What is the remaining term? f5x1 is equal to 5x2. Okay, and again on both sides 5 should get cancelled ma. Remaining x1 is equal to x2 we got. What is this condition ma? If f of x1 is equal to f of x2, then we got both elements are also equal to each other. That means given function is 1 to 1. Is it clear? First condition is proved. Now the second condition we need to show onto condition. Okay, so we need to prove onto condition ma. Let y is nothing but element in Q you should take, and f of x is nothing but equal to y, because by the definition of onto it should be exist every element in codomain have a pre-image in the domain. Right now anyway here y belongs to Q, I am taking f of x equal to y. Okay, f of x is nothing but by the defining function 5x plus 4 is there. Is it right? Write my here 5x plus 4 is equal to y as it is. Write down from this equation. From this equation you should find the value of x. Okay, x will find. So 5x as it is you should keep on the left hand side ma. This 4 I am taking on the right hand side. So here 4 is nothing but positive is there. On the right hand side we are taking no, it should becomes negative. Okay, and y minus 4, and 5x equal to y minus 4 means x is nothing but my dividing on both sides with 5. So we should get x is equal to y minus 4 by 5. This value is nothing but element in Q. Q is nothing but what ma, P by Q element should be exist. So obviously it is rational number. So it is nothing but element in Q only. Okay. So x value we have here y minus 4 by 5. So then here f of x is equal to f of, instead of x write this value ma, y minus 4 by 5. Okay, and by the defining function what is there from equation 1, f of x is equal to 5x plus 4 is there. Right now, so f of x is equal to, here we have f of y minus 4 by 5. Here f of x is equal to 5x plus 4. So substitute here instead of x this value. Instead of x here this value ma, y minus 4 by 5 you should substitute. That means 5 into x plus y minus 4 by 5 we are substituting plus 4 as it is. That's what this is. By equation 1 I wrote. Okay, and here this 5 gets cancelled ma. Okay, remaining term y minus 4 plus 4, and minus 4 plus 4 also gets cancelled. What is, we have y only. So therefore here f of x equal to y we got na. What is that condition? Onto condition only. F of x equal to y. Prove na. So therefore given function is also satisfies onto condition. Here satisfies the function 1 to 1 as well as onto. Satisfies both conditions. 1 to 1 onto function satisfy in the end. Given function is nothing but what we can say? It is nothing but bijective function or bijection. Is it clear? Yes. In this given statement, first condition is proved. Now the second part is what is there? We need to find f inverse. Okay, inverse function we'll find. Let f of x is nothing but equal to y you should take ma. Okay, and then inverse function f of x equal to y means this function you should take on the right hand side. We should get ma f inverse of y equal to y. F inverse of y equal to x, or taking on both sides f inverse. Deenike meeru f inverse function f of x equal to y is there na. I am taking on both sides f inverse is equal to f inverse of y. Okay, f inverse of x is equal to f inverse of y we can write now. F inverse of f is nothing but what ma? Identity. Is it clear? F inverse of f is nothing but identity. Identity of x is equal to f inverse of y. Identity toti, by the definition of identity, we should get x only. ఇక్కడ ఏ ఎలిమెంట్ ఉంటే అదే మనకు వచ్చేస్తుంది. Right now, so here I of x means x only. Simply you should take f inverse of y. Got now? Directly I wrote here. F inverse of y is equal to x. Or taking ఈ ఫంక్షన్ ని రైట్ సైడ్ తీసుకుంటే it should becomes inverse. Okay? ఇలా చేసినా వస్తుంది. Or we can write directly also. Anyway, here x is equal to f of x equal to y is there. Yeah, x is nothing but what we have, ma, y minus 4 by 5 is there. Yes, no? So x is equal to this one is nothing but element in Q, and x is nothing but here what is there from this condition, f inverse of y. Instead of this, right, f inverse of y. That should be is equal to y minus 4 by 5 we should write, ma, and f inverse of, instead of y I am taking x. Nothing will happen. In terms of x I am writing. Okay, f inverse of x is equal to x minus 4 by 5. Okay, for all here x is nothing but element in Q. So this is the inverse function. Second part is nothing but have to find f inverse, no? F inverse of x is nothing but x minus 4 by 5. This is the required solution. Okay, thank you, ma.